Welcome to today's episode where green steel meets red flags. Hydrogen is the clean fuel of the future. But did you know it can turn into huge problem to the blast furnace top gas? So in this presentation we are going to see what sort of safety threat is there on the top gas due to presence of more percentage of hydrogen. So let's explore how much hydrogen is too much and what we need to do about it. So in the subsequent slide, we will try to find out an answer for this. Now coming to why hydrogen in top gas is a big deal. Hydrogen offers immense benefit like clean reduction, lower CO2 emission, which is supposed to be one of the biggest benefit of hydrogen injection in blast furnace. But it also comes with a catch. It's flammable, invisible, odorless, and if it leaks into the wrong zone or mixes with oxygen, it could become huge problem in terms of explosive. That's why monitoring hydrogen in top gas is a must. So, where does hydrogen comes from? This is a now good questions and all blast furnace person should thorough about what are the source of hydrogen, or we can go through the hydrogen balance very very expert way, because that confirms what is our expectation with respect to input and where we have to monitor, modulate or control the input, so in order to get the output which is within the explosive boundaries. So there are three major sources of hydrogen in blast furnace. First, the injected hydrogen gas, which we are going to enrich. Second, the hydrogen content of PCI coal, which is around 4.5 to around 5.5%. And third, the moisture in the hot blast, often injected as steam, and sometimes even water increase add to the count. Hence, easy daily hydrogen calculation, we need to expertise in this front. So in this slide, let's simplify this for everyday use. To get the hydrogen volume from the injection or the PCI, use this basic formula. We convert the weight of hydrogen into moles, then into volume using gas law. Steam or water is also converted into hydrogen based on the H2O molecules. This formula gives us a clear daily estimate of total hydrogen input, and which is supposed to be very important. In a real blast furnace, if you see, we inject 10 kg of hydrogen using around 100 kg of PCI in terms of kg per ton hot metal, and inject 20 grams of moisture, that is normal meter cube per normal meter cube of blast, around 20 gram we are injecting. So the total hydrogen input is around coming 165 normal meter cube per ton hot metal. Assuming 40% of the hydrogen is used in reduction, that is utilization of S2 is 40%, then the unused 99 normal meter cube end up in the top gas. So what is the top gas. Anyway, top gas is a mix of CO, CO2, nitrogen, hydrogen and some steam with 99 few percent or 99% we can say 99%, 99 normal meter cube of unused hydrogen in the typical around 400 to 420 normal meter cube of top gas that gives us around 23% hydrogen concentration. This is far above the safe limit for many environments. So let's talk danger threshold. Hydrogen danger threshold is what then? Hydrogen has a lower explosive limit, as we know it is 4% in the air. The explosive range extends all the way to 75%. 75%. That's why you say that we have a very extensive range of hydrogen which mix in air to form an explosive mixture. While blast furnace top gas is mostly inert, any air increase during leak, maintenance or purging can turn this gas mixture into ticking time bomb. So now the question arises that how to stay safe? What can you do? So for these, the most important thing is install real-time gas analyzers and which is to work in a rough and tough environment. Set alarms if hydrogen crosses 10 to 12%. Purge with the inert gas during maintenance. Never allow open flames near gas fumes and always ensure blast furnace rooms are well ventilated. That is most important part. So we can say that before you inject hydrogen, know this: hydrogen is a clean path to the future, but do not let become your biggest risk. Hence, monitor top gas hydrogen. If utilization is below 40%, you are wasting fuel. If top gas hydrogen exceed 20%, it's a red flag. Safety must be guide sustainability. Thank you.